Hello friends, in this video we are going to solve these questions. Here you can see we need to determine this line integral. This line integral is dependent or independent of the path of integration. Okay, and also we need to evaluate the line integral from this point to this point. Okay, so now let me take a blank slide where I can solve this question. So there should be a C. Actually I missed it. Okay, so before we solve this question, please subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you. Okay, and if you want to follow me on Insta, this is my Insta ID, Ozaloikajit123. This is my Insta ID. You can follow me on Insta. Okay, so now let's start. Here the given integral is this is the given integral. Now you see here we can express this part as a product of two vectors. Let me show you how. So it can be written this way. Now let me give you, here you see, just wait. No, we can write this part as a function of as a dot product of two vectors. Let me show you how. So here you can write 2xyz square I cap plus x square z square plus z cos yz j cap plus twice x square yz plus y cos yz k cap dot dx I cap plus dy j cap plus dz k cap. Okay, we can write this way. Now you see, let us take this part as vector f and this one as dr vector. Okay, so then we can write this one as, we can write this as f vector dot dr vector, where vector f is equal to nothing but this part. Let me show you. So here you see, this is the vector f, this is the vector f, and vector dr is equal to dx I cap plus dy j cap plus dz k cap, right? That's it. Okay, so therefore this integral can be written as integration f dot dr, right? Now let me take a new slide where what I have taken. So now let me copy this here. You see, so here is the integral, which can be written as integration of f dot dr, where vector f is nothing but, let me show you. Let me write the vector f and dr again here. So these are the two vectors, vector f and dr. Okay, so now you see this integral, this line integral. Okay, this line integral f dot dr to be, to be independent of the part of integration, the curl of this vector must be 0, right? Must be 0. Now let's check is that 0 or not. Okay, so just wait, give me a second. So I have realized these things. Okay, so now let's find curl of vector f. So how to find the curl? So let's find the curl. Okay, so here what we're gonna have, I cap, j cap and k cap, and del x, del y, and del z. And here the coefficient of I cap is this 2xy z square, and that of z cap is this x square z square plus z cos yz. Then what we have, the coefficient of k cap is this part. Okay, so let me write that 2x square y z plus, just give me a second, okay, plus y cos y z. That's what we have got, right? So now let me take a new slide again and let me copy this card, okay, so that I can get enough space to solve this. So let me copy this and let me go to a new slide. Okay, so here is the card. So let's evaluate this. Okay, if we get this is equal to 0, then that means the integral line integral is independent of path of integration. So now for I cap, what we need to do, for I cap, we have to differentiate this, right? We need to operate this by this operation. That means we need to differentiate this with respect to y partially, then minus differentiate this term with respect to z partially. Okay, so if we do so, then what we're going to have, so here you see from the first term, what we're going to have, if we differentiate with respect to y, we're going to have 2x square z, right? And from the next term, here you see, remember one thing, this cos yz means it is a function of cos is a function of yz. Okay, so not only function of y. Okay, y, if it is function of y only, then this z can be written here. Actually, let me tell you what now you see. So consider this case, then you will get you will better understand. Here we have z, there is also z. If this cos is function of y only, then z can be multiplied here, z square. So instead of writing z square, they have written cos yz. What does it mean? That means cos is a function of both yz. Okay, so don't be confused here. That's it. So now you see, so what we can do here, if we differentiate this, we're going to use the product rule. This one should be considered as u and this part should be considered as v. Okay, so derivative of derivative of u into v is given by first function derivative of the second function derivative of the first function, right? So if we apply that, then what we're going to have, just wait. Okay, so first function derivative of the second derivative of cos yz, that's going to be minus sine yz. Again we need to differentiate this part as it is function of function, right? So if you differentiate that, so we are differentiating with respect to y partially, that's why we're going to have z only. Now plus second function, that is cos yz, and derivative of the first function derivative of y with respect to y, that's going to be 1, so we get simply cos yz. Now minus, we already have done this part. Now let's do this part. Okay, so now what we can do here, just wait, let me clean this. Okay, so now you see, as we have minus, let's start bracket. Okay, so let me use here square bracket. Okay, so if you differentiate this with sorry, not this one, if you differentiate this with respect to z, then what we're gonna have, 2x square z, then plus, again we're going to use here product rule. So first function, that is z, and derivative of this, again minus sine yz, then again if you differentiate this with respect to z now, then you're going to have y, right? You're going to have y, then plus second function, that is cos yz, derivative of the first function derivative of z with respect to z, that's going to be 1, so simply we get cos yz. That's it, right? So that's what we have got. Then minus z. Now you see, if you write minus z cap, if you write here minus, then you have to start from this side. Otherwise, if you write it plus, then you have to start from this side. Sorry, from this to this. You have to operate this by this operator. Okay, and if you write minus, then you have to operate this one by this operator first, then this one by this one. Okay, so don't be confused. Now what we're gonna have here, now you see we're gonna differentiate with respect to x, this one. So if you differentiate it with respect to x, then here you see if you differentiate this part, then you're gonna have 4x y z, that's it, right? And this is not a function of x, so that's why that's gonna be 0. Then minus differentiate this with respect to z, so again you're gonna have 2x yz, right? Sorry, not 2, that's gonna be 4. Okay, so as we have z squared, so 2 to the 4 x y z, simply that. Then plus k cap. So to find k cap, so we have to do this one first. So this is, if you differentiate this with respect to x, then you're gonna have 2x square, sorry, not x square, x only, z. Then this is not a function of x, so that's going to be 0. Then minus differentiate this with respect to this one, and if you differentiate it with respect to y, then it's going to be 2x z square again. So here you see these two clearly cancels, right? So that's going to be 0. So what we have got here, what we have got I cap and 2x square z, so y into z, and minus plus, that's going to be minus yz sine yz, right? Then plus cos yz, then minus, remove this bracket, 2x square z, this minus plus minus, again this minus, that's why minus plus, right? Sine y into z, yz sine yz, right? Then this plus sign, because of this minus, that's going to be minus cos y z, that's what we have got. Then minus 0 z cap, then plus 0 k cap, that's what we have got from these two, right? So that means these things becomes 0. So here you see this one cancels this one, this cancels this one, then this cancels this, so finally we have got 0, right? That means therefore the integration c f dot dr is independent of the part of integration, is independent of part of the integration, right? Now you see, so we have done one part. Now let's move on to the next part. And here you see in this question we need to evaluate from this point to that point. So in order to evaluate, let's do one thing. Let me first copy this f vector dr vector again. Okay, let me copy these things. Just wait, let me copy this part again. Okay, so let me take a new slide. Now you see, let us consider that this function, this vector f is a vector can be considered as gradient of some scalar. So let me consider that phi is some scalar. Since a vector can be expressed as gradient of some scalar, right? So that's why we have considered this way. Now you see what we can do here. Now you see for a scalar function phi, okay, so for a scalar function phi, which is a function of x comma y comma z, its complete derivative is written as del phi by del x dx plus del phi by del y dy plus del phi by del z dz. It is written this way, right? So now here you see, so we can write that d phi is equal to del phi by del x dx plus del phi by del y dy plus del phi by del z dz. So we can express this one again as a product of two vectors. Okay, so if we do so, then what you can have, del phi by del x I cap, suppose del phi by del y j cap plus del phi by del z k cap, right? And dot dx I cap plus dy j cap plus dz k cap. So if you find a dot product of this one and this one, then again you're gonna get this, right? So here this is nothing but grade of phi, right? Grade phi. So you know this del is equal to del x I cap plus del y z cap plus del z k cap, right? So grade phi means this operates on phi, right? So hope you know these things. So that's why we can write, grade phi dot dr. This part is dr vector, already we have mentioned here, right? Now you see, as we have considered that this f, which is equal to del phi, that means this is equal to del phi, so we can replace this del phi by this, right? So we can write this one as f dot dr. Okay, f dot dr. So f dot dr. So if this is the case, then instead of f dot dr, what you can write? So f dot dr is nothing but this part is f dot dr, this part is f dot dr, right? So this part here, you see the integrand part, right? This is f dot dr. So we can replace this f dot dr by this part. Okay, so if we do so, then what we're gonna get? So let me copy this part. So we have got del phi is equal to this one. So that means if you integrate this, that means that's gonna be the integration of this part, right? Which we need. Okay, so first let us simplify this. So how we can simplify this? First let's do multiplication. Okay, so let's open the brackets, twice x y z square dx, then plus x square z square plus, sorry, not plus, dy should be there, then plus z cos yz dy, then plus 2x square y dz plus y cos yz dz. That's what we have got. So this is nothing but del phi. So now let me copy this last step and let me go to the next slide. So this part is nothing but f dot dr, right? This is nothing but f dot dr. So what we can write, this is nothing but f dot dr. Okay, f dot dr, right? So hope you have understood this. So here you see, okay, right? So now what we can do here, if you see this, let me show you something. Yeah, if you see these three terms, let me write these three terms first. Just wait. This is the first term, and let me write the next term, this one, plus then this. Okay, then let me write plus this term, that is z cos yz dy, then plus that means I have rearranged the order of the terms. Okay, so that's it. That's what I have done only. Okay, nothing is changed here, just only the order of the terms are changed. Okay, so here you see, just wait what I have done here. Okay. Okay, so this is what we have got, right? So now you see, if you observe these three terms, okay, here you see we have dx here, right? We have dy here, okay, and we have dz here, okay. So it can be considered this way, that here you see, here we have twice x, so we can consider this is the derivative of x square, right? And here y and 2z square. Here we have z square and x square as well, both x square and y square. So here we can consider 1, which is derivative of y with respect to y. We can consider that way, right? So if you consider that way, now you see, if you differentiate with respect to any unknown variable, suppose let me differentiate with respect to suppose p, okay, then what you can do, now you use the product rule u v w, okay, then derivative of the first function, that is 2x then yz square, right? Now you see, as we are differentiating with respect to p, okay, that's why we should write dx by dp, right? Now then second function, derivative of the second function, x square then dy by dp we're gonna have, then z square, then plus derivative of the third function, first function, then into derivative of the second function. If you differentiate this, then it should give 2 into z, then as we are differentiating with respect to p, that's why dz by dp should be written. So you can cancel dp, then what you're gonna have, you're gonna have these things, right? 2x y z square dx plus x square dy, so it can be written this way, z square, then plus x square 2 can be written first, this 2, then y z dz, right? Y z dz. So here you see I have missed a y here, sorry, z, there should be a z, okay. So let me check this one as well, so there should be a z, okay. So let me go back to the previous slide if I had made any mistake. So let me check the term here, this one, right? There should be a z, I have missed that, okay, there should be a z, right? So sorry for this mistake, and okay, so now this is what we have got. So this part is nothing but this part, right? So which can be replaced by dx square y z square, right? So let me write this one as dx square y z square, right? Then plus, if you check the next part, here you see, now let me clean these things, okay, those things are not required now. So cos yz, so you know derivative of sine is cos, so let me consider sine yz. If you differentiate it with respect to any unknown term, suppose unknown variable, suppose let's suppose p, then it's gonna be cos yz. Now then again it is function of function, if you have to differentiate it then with respect to p, then if you use the product rule here, then you're gonna get cos. So let me show here, just wait, let me bring it to this side, okay. Now you see cos yz. Now if you use the product rule here, what you're gonna have, y del z by del p, then plus z dy by dp, not del, dy by dp. Then if you multiply, then what you're gonna have, this from this one, y cos yz dz by dp, right? Then plus z into cos yz dy by dp. That's what you're gonna have. So this is nothing but here you see d by dp of sine yz. So here dp can be cancelled. Okay, so that's why this is nothing but what? So this is nothing but this one, right? Z cos yz dy, z cos yz, sorry, that's supposed to be dy. Okay, sorry, I made a mistake here. So dy by dp. Okay, so dp cancels, right? And this term is nothing but y cos yz dz, right? So that's why this can be replaced by d sine yz. Okay, so now just wait, let me clean these things, just give me a second, right? Okay, so what we can do, we can replace this part by d sine yz. Okay, so we need to find the integral of line integral of f dot dr, so which is equal to integration of d phi. Okay, so which is equal to integration of d x square y z square plus integration of d sine yz, right? So if you integrate this, then what you're gonna have x square, this two will be removed on integration, right? Plus sine yz. So here you see, now let's go back to the question. Here you see, we need to evaluate the integration from this point to this point, right? So now let's go back to the last slide. Okay, so here you see, we need to differentiate it from 1, 0, 1 to 0, pi by 2 to pi by 2, 1. Okay, these are the 2 points from where we need to between which we need to find the integration. So this is the upper limit, this is the lower limit, right? So in that case, so integration, this line integral of f dot dr from this 1, 0, 1 to 0, pi by 2, 1 is given by x square y z square plus sine yz. Okay, so integration of this from 1, 0, 1 to 0, pi by 2, 1. So that's what we have got. So now let me copy the last step and let me go to the next slide. Okay, so here is the new slide and this is the last step we have got. So now let's put these values, upper limit first. Then here you see, if you put 0, x equal to 0, this whole term gonna be 0, that's it. So here no x, so that's why we can get sine pi by 2 and z is equal to 1, so simply sine pi by 2. Then minus, if you put the lower limit, here y is equal to 0, so this term gonna be 0, and here also y is equal to 0. Here also we have y, so that's gonna be sine 0. Sine 0 is 0, simply 0 we have got. So we have got sine pi by 2, which is nothing but equal to 1. So this is the value of the integral. So hope you have understood this. So thank you for watching this video, and if you like my video, please do share with your friends, inspire me to create new content for you and help me to grow my channel. Thank you so much.